Okay, that last video was getting a bit long, so this is the new topic we're going to cover in class tomorrow after we take the quiz. If you want to know what's on the quiz, I suggest you watch not yesterday's video, but the previous video that I just uploaded. So what we're going to be doing is using the Pythagorean theorem to find the distance between 2 points. There's a nice description and example of that on your unit overview. And here is my explanation. We have these 2 points floating around in the coordinate plane, and we want to know how far it is. That line's a little off. We want to know how far it is to get from one point to the next. And we're going to apply the Pythagorean theorem. This diagonal line could very easily be the hypotenuse of a right triangle. So if we count down and over along the coordinate plane, we can put a point right there, which seems to be located at the x-coordinate of this point and the y-coordinate of this point. And you can just count it out: 1, 2, 3, 4, 5, and down 1, 2. So 5, -2. And now this side of the sort of imaginary right triangle that we're adding in here seems to be 3, 4, 5, 6, 7, 8 units long. And this side seems to be 1, 2, 3, 4 units long. And you can see that both visually and mathematically. I think visually is a little easier, but I'm going to show you mathematically as well. The x value here is 5, and here is -3. So if we take what's called the absolute value of the difference, 5 minus -3 equals 8. All the absolute value means is we're going to take whatever our answer is and make it positive. Here, the difference between these points, 2 minus -2 equals 4. So we'll probably just do it visually, but I don't know. I mean, finding the difference between those two really isn't all that difficult. And now we use the Pythagorean theorem. 4 squared plus 8 squared equals 16 plus 64, which equals 80. And the square root of 80 is the distance between our 2 points. .94. And so that's what I call a medium difficulty problem, because one of the points is here with negative values. Here is an easy problem. We just connect the 2 points so they are behaving like the hypotenuse of a right triangle, and then we figure out where would the 2 legs intersect. If we just draw vertically down this way and horizontally over this way, we get this intersection point of a right angle at, let's see, it's going to be at 8, 1. And now again, you can visually, 1, 2, 3, 4, 5, 6 is the length of this side, or 1, 2, 3 is the length of this side. We can also do 8 minus 2 equals 6, or we could do 1, 2, 3, 4. You know what? This point is mislabeled. This should be 4. 1, 2, 3, 4. So we could also do 4 minus 1 to get 3. So visually or with subtraction, you're going to get the same thing. And then we apply the Pythagorean theorem to find the length of this hypotenuse, that is the distance between those 2 points. So that's 9 plus 36 equals 45. Square root 45 is about whatever my calculator says it is. A little less than 7, somewhat more than 6. 6.71 after rounding. So the distance between those 2 points is 6.71 units. Now this one down here is what I call a hard problem. It's really not all that hard. We're going to do the exact same thing, and then we're going to add one extra step on at the end. Here I've created a scale. So every one of these units in the coordinate plane, each one of these boxes is representing 2.3 miles. So when we're done with the whole thing, we're just going to multiply our final answer by the scale. So first, connect the 2 points. We want to find the length of that diagonal line. That diagonal line is the hypotenuse of a right triangle. So we draw vertically down from this point, horizontally over from this point until we create a right angle. This point right here looks like it's located at 1, 2, 3, 4, 5. 1, 2, 3, 4. So that is a point 5, -4. And of course, you can see how the x-coordinate of these 2 points is the same, and the y-coordinate of those 2 points is the same. And it would have to be that way. It could not be any other way. Visually, we can see that this is 2, 3, 4, 5, 6, 7. And here it is 4 plus 4, 8. So we're going to be doing 7 squared plus 8 squared. But of course, we can do the subtraction method. 5 minus -2 is 7, subtracting the x-coordinates. And for the y-coordinates, 4 minus -4 is 8. So we have mathematically confirmed what we discovered visually. 7 squared plus 8 squared is 49 plus 64, which is going to be, what is that, 113, I believe. So the square root of 113 is this line segment right here. Square root of 113, that's right around the halfway point between 10 and 11. 10.63. So this line segment is 10.63. However, we're not quite done yet. We have this extra step of applying the scale. Each one of these little boxes represents 2.3 miles. So the distance between these 2 points is not 10.63. It is 10.63 times 2.3 miles. So 24.45 miles would be the final answer here. Alrighty. And we will be doing this in class on worksheets and warm-ups and practice problems that we do together. And the DCA is scheduled for this coming week from Friday, after your 4-day weekend. And then we'll be moving on to a new topic. So if you find these videos helpful and you want to see more, please like, comment, and subscribe.